But what we want to know is how quickly does it come back? So in that first study, both groups losing muscle. We take off the cast, we remobilize them, they're back walking, not doing anything intensive, kind of a recovery or like physiotherapy type session, but just back moving. And what we saw, which was the key finding from the paper, is that the muscle protein synthesis rate, so it's called myofibrillar synthesis rate to give it its full name. You take it using muscle biopsies, so they stick a little tube in your leg and pull out a section of muscle.
Chunk.
Yeah, not very nice to look at. It's not fun. People don't generally come back for a second trial. But we saw 4 times the increase in muscle protein synthesis in that recovering leg in that group. So,
and that was receiving a standard dosage.
So actually, that was a slightly higher dose because we balanced it against the milk protein concentrate that was being used. But the purpose of that study, and it's going back to that thing, if you have to prove everything out and kind of demonstrating it from square one, from having zero evidence to building that evidence set. What we wanted to show there is that the protein that has been broken down, it's not working as a protein. It's milk protein, that's a solid, high-quality dairy protein. It's got the branched-chain amino acids. It's got the leucine content. So if we're seeing anything different from Peptistrong, that can only be a peptide-mediated effect. So the reason peptides are so cool is because they're signaling molecules. They don't get broken down and used as proteins. They're actually telling the muscle, in this case, to do something, telling the cell to do something. And what we see there is a very clear and pronounced upregulation of muscle protein synthesis. So 4x. It's not 5% more or 2% more. It's a massive 400% increase there. And that's what we saw. So this was like, for us in that first study, the first thing we're doing is like, we did all this clever stuff in the lab. Does it really work? And you see something which is so kind of undeniable that it's like, yeah, we've got something here. Then what's going to come next? And that wasn't the only finding in the study. We also found, and this again really interesting, because when you immobilize a muscle, if you get injured, if you're a sports player, it's kind of probably the more usual kind of circumstance we see this. You lose muscle quite rapidly if a muscle's immobilized. So if anyone exactly. They break a leg, break an arm, go into a cast, that comes out. They've got one arm that's still muscular and then skinny arm. That muscle comes back relatively quickly. Depends on the population. If you've got a young male who's training with weights, high protein diet, testosterone filled, they're going to get that muscle back much quicker than a 70-year-old woman who's fallen and injured a hip or something like that. They're going to have a very tough time.